So here's another example from this particular test. So in how many ways can the word quick be arranged so that Q and K are separated by at least one letter? Okay, so this is an interesting one. And students will run into some problems if you haven't seen this before. And how do we kind of think about this example? So quick has really 5 different types of letters, right? So Q, U, I, C, K. And you know that if you have 5 different letters, so the total number of arrangements, would have been 5 factorial, which is 120. That is if, we didn't have any restrictions. Now we do have a restriction. So our restriction is that Q and K are separated by at least one letter. Now you can try, to pick your cases, right? And then see, okay, are they separated by 1, by 2, by 3, and so on and so on. And it would create a lot of cases for you, and it's actually quite a bit of a headache. So what you can do instead is kind of negate the problem and say that, okay, so in how many different ways can this word be arranged? Well, it can be arranged in 120 different ways in total, minus, so I can subtract, so I can negate the problem by saying, when are they together? Okay? Because if I figure out how many times they are together, and I subtract it from the total, that's going to actually give me what I want. So this is kind of negating the problem in some sense. So let's do that. So here is my total number. And now I want to know, okay, so when are they together? So when are they together? Well, so that means you either have Q, okay, K, so that can happen, right? Or, you can certainly have either K and Q. So here they're also together, so they're not separated by anything. Now, because we have 2 different letters, so really this is just 2 factorial, right? So 2 times 1. Different ways of rearranging, which is just the swapping. So that's 2 factorial ways, okay? How you can swap, so either Q, K, or K and Q. And now that also leaves me with another 3 different letters that I have. That would have been the U, the I, and the C. So in total, so this acts as 1 unit, all right? So we have 1 unit. This is going to be your Q, comma, K, and we can do that 2 factorial ways. And then you still have 1, 2, 3 other letters, which is the U, the I, and the C, which we can now start rearranging. So I have 1, 2, 3, 4 different units. So this is going to be 4 factorial ways that I can rearrange these. And then, of course, I'm going to multiply it by the 2 factorial because I can swap the Q and the K, okay, over. So 4 factorial, I guess, is 24 times 2. So that's going to be, what, 48, right? And now if I take the total, which is 120, so 120 minus when they are together, which is 48. So that would have been, so 120 minus 40 is 80, and so I guess that's 72. So that is 72 different ways that they can be arranged such that there is at least 1 letter which separates this Q and K. So we've kind of used the opposite. Find how much the total, how much when they're together, and then just subtract them. And then that would have completed this particular example. Okay, so it's another one done.